Hello everyone, very good evening and welcome to the BYJU'S exam prep. This is Sanjay Rathi. Now today we will discuss some important numericals from EDC, that is electronic devices and circuit. Okay, and this is a PYQ series, means we are covering here questions from 2021, 2022, 2023. Why? Because it is based on what latest pattern and you will get idea about MCQ, MSQ, numerical answer type question and what is the level of question. Okay, and you can compare the what about the level of the 2021, what is in 2022 and what is in 2023, so that we can expect or we anticipate questions in 2024, guys. Okay, now this is a PYQ series for GATE 2024, last 3 years question paper. And then this is my introduction. Myself Sanjay Rathi. I am having 22 years of teaching experience. I have trained more than 1 lakh students for these competitive exams. I have qualified and selected for engineering services exam, and these are my ranks, guys. Okay. And this is my Telegram channel, Electronics by Sanjay Rathi, where I will upload the PDF of this session. Go through it. If you find any difficulty, then tag me on my Telegram channel. Or if you want to give detailed answer for all this question, yes, you can also post so that I can check that answer, whether it is correct, or if suppose we are doing some silly mistakes, then I can check that where we are doing the silly mistakes. Okay. Now, so this is Electronics by Sanjay Rathi. Then guys, we will start with what 2021. Questions from 2021 without any delay. First question in 2021, that was the MCQ, multiple choice question, 1 mark question. Normally we are getting question from semiconductor. So there are total 6 main topics: semiconductor physics, PN junction, third one is what BJT, then MOSFET, then MOS capacitor, and what special diodes. So you have to get the command over all the topics if you want to solve questions from EDC. So this is the question P type. This is the EV, that is the EF is called Fermi level. This is 0 and that is the length up to L. There is an energy gap. Now the energy band diagram of a P type semiconductor bar of length L under equilibrium condition. The Fermi energy level EF is constant. Under equilibrium, always remember that Fermi level will maintain a constant level. The valence band EV is sloped. Sloped means it is near to EF, it is far away from the EF, means at this point the concentration of hole is very high, at this point the concentration of hole is small, and that's why this gap is very, very small. Okay, remember this. Gap decreases means concentration increases. Doping is non-uniform along the bar. The difference between the energy level of the valence at the two edges of the bar is del. From this point to this point, that gap is del. If the charge of an electron is Q, then the magnitude of the electric field developed inside this semiconductor bar is. What is the electric field developed inside this bar? Okay, very, very simple question. Watch this, guys. Answer is given as 2 del by QL, 3 del by 2QL, del by 2QL and del by QL. Now, this is the gap, right? Here we are having gap between EF and EV, that this is E1. Here we are having the gap between this E2. What is the E1 minus E2? That E1 minus E2 is what del. Means when we are moving from this point to this point, we are increasing the concentration of Na except our impurity. At this point the concentration is less, at this point concentration is more, that's why this gap decreases. And what is the difference? Del. If the del is the difference, so that is in what? Energy. When it is divided by Q, you will get what? Volt. When it is divided by Q, you will get volt. And when the volt is divided by L, you will get what? Electric field inside the bar. Why we are getting the electric field? When there is a non-uniform doping, then what will happen? There will be a diffusion current and the hole will start moving from higher concentration to lower concentration, guys. If the higher concentration to lower concentration, then this is the concentration. At this point, the concentration is high hole. And at this point, concentration is low. What will happen? The hole will move in this direction from higher concentration to lower concentration. And what about the electron? What about the current due to holes? It will in the same direction. That is RP, AJP. And this is given by A, Q, dP, dP by dx. This is called diffusion current. Now, in an open circuit bar, what should be the current? 0. To counter it, there should be drift current. When there should be drift current, and it should be in opposite direction so that the total current will be 0. And that's why electric field will develop. And because of that electric field, the hole that will oppose the flow of holes. And that's why at this point, that is the higher concentration, at this point, that is the lower concentration, the electric field will develop in opposite direction, and it will force the hole, or it will provide the drift current so that total current will be 0. So what is the formula for the electric field? First of all, energy divided by Q, you will get the volt, that is the energy difference divided by Q into what? Divided by L, and that is called electric field developed inside the bar. Okay, so that will be the answer for first question. Now next one, so that what is the answer for? D. In my number of sessions, I have derived all the formula for this type of questions, so please go through it. Then second one, if you find any difficulty, then please tag me so that I will arrange session for you. Next one, a bar of silicon is doped with boron concentration of 10 to the power 16. Boron, remember, it is a trivalent, Na, 10 to the power 16. Assumed to be fully ionized, 100% ionization. To light, now it is exposed to light such that the electron hole pair are generated throughout the volume of the bar at the rate of 10 to the power 20. What is the generation rate? 10 to the power 20 per centimeter cube per second. Per second. If the recombination lifetime is 100 microsecond, intrinsic carrier concentration of the silicon is 10 to the power 10. This is only 1 mark question, guys. Remember, 10. And assuming 100% ionization of the boron, then the approximate product of steady state electron and hole concentration due to this light exposure is. What is the steady state product of concentration of electron and holes? You have to find. Okay, Venkat, you want the session for this? So I will arrange for that so that we will discuss all the topics here on semiconductor physics, right? So please try to attend, just you will get the schedule for that. I will upload the schedule on my Telegram channel. Now watch this. Everything is given here. Na is given, G is given, tau is given, Ni is given, and then uniformly doped means, uniformly light throughout the bar means we are giving the light here throughout the bar. So throughout the bar, new hole electron pair generated. When new hole electron pair generated, there will be the change in the concentration of electron as well as change in the concentration of hole. And that will remain same. Why? Because when new hole electron pair generated, to change in the concentration of electron and change in the concentration of hole will be equal. Then how we can find the product? For example, first of all, 100% ionization. So what is the P here? P is given by nearly equal to what? Na, and that is the 10 to the power 16. Why? Because the intrinsic carrier concentration is very less, 10 to the power 10 as compared to 10 to the power 16, and that's why P is nearly equal to what? Na. Okay, that is the concentration of hole. It is given 10 to the power 16 per centimeter cube. Now what is the concentration of electron initially? This is called P naught N naught, and that is given by concentration of electron according to mass action law, Na, that will become 10 to the power 20 divided by 10 to the power 16. This is the 10 to the power 4. Okay. Now, when we are giving the radiation, the concentration of electron will change, at the same time concentration of hole will change. So what is the change in the concentration of electron and hole? That is given by generation rate into mean lifetime. What is the generation rate here? It is given 10 to the power 20 and mean lifetime 100 microsecond. 10 to the power 20 into 100 microsecond. 10 to the power minus 4. 6. Micro means 6. It will become 10 to the power minus 4 and it will become 10 to the power 16. 10 to the power 16. Now, what is the new hole concentration? That is given by P naught, that is initially, plus what? Change in the concentration. 10 to the power 16 plus 10 to the power 16 is equal to 2 into 10 to the power 16 per centimeter cube. What is the new electron concentration? N naught plus del P, del N. Then it is what? 10 to the power 4 plus 10 to the power 16. This is negligible as compared to 10 to the power 16. It is nearly equal to 10 to the power 16. Then what is the product here? 2 into 10 to the power 16 into 10 to the power 16, that is nothing but 2 into 10 to the power 32. That is the product. Okay. So this is the answer for this question. Okay. So this is the product of NP, 10 to the power 16 after thermal agitation when we are giving the radiation here. So 2 into 10 to the power 32. Is there any answer? Yes. 2 into 10 to the power 32. And what will be the unit? But this is per centimeter cube. This is per centimeter cube. That's why the unit will become per centimeter 6 or 10 to the power centimeter minus 6. So what is the unit is correct here? Yes. What is the unit given? 2 into 10 to the power 32 centimeter minus 6. Power is what? Minus 6. So please be careful about the unit. Now next question. That is the second question. Now third one. Again, now we have solved 2 question, 1 mark question. Now MCQ 2 mark question, multiple choice question and 2 mark question. And that is what is the answer for this one? Silicon PN junction is shown in the figure. Here it is a silicon PN junction. The P area is large, N is small. The doping in the P region. This is not MCQ. This is numerical answer type question. Sorry. NAT. There is no negative marking. You have to solve this type of questions. 0.2 micrometer, this width is given. 1.2 micrometer, this P area is given. The length of the P area is 1.2 micrometer. Then the doping in the P region is 5 into 10 to the power 16. Na is equal to 5 into 10 to the power 16. Nd is equal to doping in the N region 10 into 10 to the power 16, means double of Na. 2 times of Na. The parameter given built-in voltage, that is called VBI or V0, that is Vt log of Na Nd by Ni square. No need to calculate because it is given 0.8 volt. Electron charge is given 1.6 into 10 raised to power minus 19 epsilon naught. It is given standard value. Relative permittivity is given 12. Always remember, farad per meter is given. You have to use the farad per centimeter. Why? Because the concentration is given in what? Per centimeter cube. Relative permittivity, the magnitude of the reverse bias voltage that would completely deplete one of the 2 region, P or N, prior to the other, rounded off to 1 decimal places. Okay. Now watch this. Here the concentration is low. Here the concentration is high. Now if this is the case, then this is only 0.2 micrometer and this is 1.2 micrometer, and we are just making it reverse bias by external voltage VR. You have to find the VR, so that what will happen? Depletion layer will increase. Depletion layer means here we are having the acceptor ions, here we are having the donor ions, only immobile charge carriers. There is no electron, there is no hole. This is called depletion layer. Now, depletion layer in P region is multiplied with the concentration in P region is equal to a depletion layer in N region multiplied with depletion layer Nd and Wn. Depletion layer in N region multiplied with the concentration. Okay. They please watch. Already I have taken one session on that. And last year in 2023, little bit less, but in 2022, number of questions. right? Number of questions from what? Electronic devices and circuit. So sometimes we are getting 10 marks, 12 marks question, 8 marks, or 8 to 15, it may vary. Okay. Now NAWP, NDWN, and also analog also depends upon what? Okay. Now Na into WP is equal to Nd into Wn. Watch, right? Now from this formula, if Na is less, then WP will be high. Na is less, how much times? 2 times. Means Nd is 2 times of Na. It is clear that WP is what? 2 times of Wn. So that the product will be same. So 2 times of Wn means what? If suppose I am assuming that this is depleted first. If this is depleted first, then what is the Wn? Wn will become 0.2 micrometer. So what will be the WP? 2 times of Wn means this will increase up to what? This point. And what is this? 0.4 times of 0.4 micrometer. Yes, it is possible. So one area is completely depleted. This area is completely depleted. And this is depleted up to this point. But again, 0.4 micrometer is depleted. Remaining what? 8.8 micrometer is here. Okay. Now, yes, it is possible. Then, what is the question asked here? The magnitude of the reverse bias voltage that would completely deplete one of the two regions, P or N, prior to the other. Now, what is the total depletion width? The total depletion width is, sir, how Na and Nd was taken in question? It is given, yes, it is given in a question now. Na, what is the P region? What is the doping in P region? 5 into 10 to the power 16, doping in 10 into 10 to the power 16, double. That's why it is given, right? Now we have the total depletion width. What is the total depletion width here? WP plus Wn, that is equal to 0.6 micrometer or 0.6 into 10 raised to power minus 4 centimeter. Okay. Then what is the formula here? Formula is V0 plus VR, that is called built-in potential, plus VR, that is called Vj, junction potential, is equal to Qn upon 2 epsilon s into W square. What is the N here? N is nothing but Na Nd by Na plus Nd. So what is the Na? That is, you can find, that is the 5 into 10 to the power 16, 10 into 10 to the power 16 upon 5 plus 10 into 10 to the power 16. Cancel out, that is the multiplication, and then you will get the 50 by 15 into 10 to the power 16 means 10 by 3. That is the 3.33. First of all, N. Okay. Then this is the Q know, N know, epsilon s, W square, everything is known. Then you can directly use this formula. Okay. Use your calculator, guys. Built-in potential is given as 0.8. You have to find the what is the voltage applied in reverse direction, means VR. What is the Q? 1.6 into 10 raised to power minus 19. What is given? Q. 1.6 into 10 raised to power minus 19 into N. 10 by 3 into 10 raised to power 16 into W square. W square is 0.6 into 10 raised to power minus 4 square, that is the W, upon 2 into 12, that is the relative permittivity of semiconductor, into 8.85 into 10 raised to power minus 14 farad per centimeter. You have to convert it. And then, guys, you can find, yes, now you can find the value of the VR. Now you can find the value of VR, guys. You will get the exact value. I think that was something 8 point something. So yes, please everyone try to find that. Okay, so that is, in this way you can solve this question. Okay, now what is our doubt here? I just NA and D was taken in question. It is given. Yes, sir, you kept holes is in reason. Hole in this reason. Why I have kept? Sir, can I get the sufficient marks if I left the EDC? No. You can get the sufficient, but if you want to get the top rank in that, or just want to qualify, right? Okay. Now, so that is the case, guys. So this is the reverse bias. P side is connected to what? This is the P side. Here we are having the holes. This is P side, this is N side. P side is connected to negative, N side is connected to positive. That's why it is reverse bias. And because of that reverse bias, depletion layer increases. And depletion layer increases, and then you can find, that is your part, guys. Calculate it and find the value of the VRO. By how much voltage it is reverse bias. So this is the question. Answers are available, guys. Don't worry. Already. Okay. So the magnitude of reverse bias voltage, that would completely deplete one of the two reasons prior to the other reasons. Okay. Then next question. So directly, when NA and ND are comparable, always find the N by using this formula. This is a scholarship test, guys. On the 15th of October, that is coming Sunday, you can give the scholarship test. Okay, and window will be open from 9 AM to 9 PM. You anytime 1 hour scholarship test you can give, national level scholarship test. Get up to 90% off on our program. This is golden opportunity for you, and you can start your journey with us. Second important thing, is it possible to cover the GATE 2024 syllabus timely? Right? This is workshop taken by Abhinav Negi sir, highly experienced faculty here. 11th of October, Wednesday, 7:30 PM. Right? And you can ask your all the doubts about the strategy, about all other things. If you have any queries related to GATE examination, and that is the workshop for you. Then, guys, now next 2022. In 2022, that first question is, consider a long rectangular bar. No, take a statement 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So which points are important? That is how we can judge. कितनी तेजी से आप निकाल पाते हो ना, वो ज्यादा इंपॉर्टेंट है. अब इतनी सारी लाइन पढ़ने में ही आपने 5 मिनट लगा दिया, then it will become very difficult. Consider a long rectangular bar of direct band gap p-type semiconductor. The equilibrium hole density is 10 to the power 17 and the intrinsic carrier concentration is, you can write equilibrium hole 10 to the power 17 and the intrinsic carrier concentration is 10 to the power 10, very less as compared to that. Electron and hole diffusion lengths are 2 micrometer and 1 micrometer. Diffusion length Ln 2 micrometer, LP, this is called diffusion length, 1 micrometer. The left side of the bar is uniformly illuminated with a laser having photon energy. For example, this is the left side of the bar. We are giving radiation at one end. Is uniformly illuminated with laser having the photon energy greater than the band gap of the semiconductor. If the energy is greater than the band gap of the semiconductor, then definitely electron will switch from valence band to what? Conduction band, and there is a generation of hole electron pair. The meaning of this line, right? Then excess electron hole pairs are generated only at x is equal to 0 because of the laser, only at this point. This is the x is equal to 0, and we are moving in this direction. This is the positive x direction. The steady state electron density at x is equal to 0 is 10 to the power 14. It is talking about the minority carrier because it is a p-type bar. So what is the concentration? Steady state means N0 is 10 to the power 14. 10 to the power 14, the steady state electron density. Due to laser illumination, under this condition and ignoring the electric field, the closest approximation of the steady state electron density at x is equal to 2 micrometer you have to find. X is equal to 2 micrometer you have to find. And what is the diffusion length of the holes? 2 micrometer. Means you have to find the electron concentration exactly at diffusion length of electron. Okay, so what is the definition of the diffusion length? A diffusion length is the length where the electron concentration will reduce by 1 by E factor of what? The concentration at x is equal to 0. Then directly you can solve this question within 10 seconds. But remember, this is the diagram. This is thermally generated charge carriers, NP naught, and this is the concentration of electron. Now, what is the total concentration of electron? That is given as 10 to the power 14. And according to mass action law, NP is equal to Ni square. So, what is the concentration of electron? Ni square, this is called N naught. 10 to the power 20 divided by 10 to the power 17, that is nothing but 10 to the power 3. This is given, that is the concentration of hole is given 10 to the power 17 and intrinsic carrier concentration is given as 10 to the power 10. So what is the minority charge carrier? This is the N naught only, so this is the N naught. And what is the exact concentration exactly at x is equal to 0? 10 to the power 14. Now it is exponentially decreasing. When it is exponentially decreasing, so what is the concentration at any point? It is given by N naught plus excess hole concentration, N naught plus excess hole concentration, e raised to power minus x by ln. X by ln. Ln is the diffusion length. Sound is perfect? Okay. Now, what is the excess hole concentration? This is the total hole concentration is given. If this is the total electron concentration, not hole, electron concentration it is given. This is called N0. So, N0 is equal to N naught plus what? Excess hole concentration. So, what is the excess hole concentration? Total hole concentration means thermally generated, this is the, according to this concentration, this is the initially, what was the whole electron concentration? Then this is given as, what is the electron concentration at this point? N is equal to 0, 10 to the power 14 minus what? 10 to the power 3, that is nearly equal to 10 to the power 14. Because that is very, very less. Now, this is 10 to the power 3 plus 10 to the power 14 e raised to power minus x by ln. This is the formula. What is the ln? 2 micrometer. And what is the x? It is given 2 micrometer. So exactly at 2 micrometer, what will be the concentration? This is nothing but ln. So when this is negligible, so this will become 10 to the power 14, 2 divided by 2 e raised to power minus 1. And what is the e raised to power minus 1? 0.368 or 367 into 10 to the power 14 per centimeter cube. That will be the answer. So you have to use this formula. And this is N naught is negligible, N dash 0 is 10 to the power 14. Already I have calculated. This is called excess electron concentration at x is equal to 0. This is called total hole concentration at x is equal to 0. Why we are talking about the x is electron concentration? Because it is p type bar. So it is a minority carrier in p type. That is the electron. And this phenomena is called what? Low level injection, guys. Okay. So that is the case. Okay then. Next one. This is the answer. 0.37 into 10 raised to power 14. This is a previous year question discussion again, Venkat. If you want, then because of recombination generated and then again when the electrons are moving, they are recombined with the holes. Large number of holes are present. When electrons are diffusing from this point to this point, to higher concentration to lower concentration, they will recombine with what? Holes. Large number of holes are present here. Why holes are present here? P type bar, or we are giving radiation on at one end only. Because of recombination, exponentially decreasing function. Okay, that is the reason. This derivation is very, very important one. This formula, every time we are getting question from this portion in EDC. Now, next one. in a non-degenerated bulk semiconductor. Degenerated means doping is very, very high. Non-degenerated means doping is moderate. So non-degenerate bulk semiconductor with electron density n 10 to the power 16. The value of EC minus EFN, directly draw, think about it. What is this? Fermi level. EC minus EFN is 200 milli electron volt, where EC and EFN denote the bottom of the conduction band and electron Fermi level. As you know, assume thermal voltage as 26 millivolt VT. The intrinsic carrier concentration VT is given. What is the VT given? 26 millivolt. EC minus EFN given 200 milli electron volt. Right? Assume the thermal voltage. The intrinsic carrier concentration is 10 to the power 10. In every numerical, we are using 10 to the power 10 per centimeter cube. But always check what is given in the question. N, for N is equal to 0.5 into 10 raised to power 16. That is the concentration of electron. The closest approximation of the value of EC minus EFN. When the N is 10 to the power 16, this is the condition for 10 to the power 16. But when the N reduces half, just it will reduce. It will become half of the previous value. Then what will be the gap between EC and EF? Tell me, it will increase or it will decrease? We are decreasing the concentration, just we are making the concentration half. Then what about the gap between EC and EFN? Watch this. This is EV, this is EC, and where is the Fermi level? That is the Fermi level. Non-degenerated EC, EFN. Initially, this gap was given as 200 milli electron volt. Okay. When the concentration. So, what is this gap? This gap is given by this gap EC minus EFN KT log of NC, that is called standard density of state in conduction band, NC by N, concentration of electron, NC by N, that is the concentration of electron it is given. This gap, initially this gap, this is the equation number 1, initially this gap is given as 200 milli electron volt. Okay, and that is KT log of NC by N. Okay, this is the N1, equation number 2. You can put the N1, and N1 is what? It is given 10 to the power 16. Now, what is the new gap? Means it is required EC minus EFN. What is the new gap? The Fermi level will shift. EC will remain same. This is the EFN1. Now is equal to KT log of NC by N2. What is the concentration? Change in the concentration. Or if you want to write the general answer, then yes, it is the first case. EFN1, this is the gap, this is the second case. Now what we can do, because when we are decreasing the concentration, the gap will increase. Definitely the gap will increase because we are decreasing the concentration. The new Fn is here. This is the 1, this is the 2. This gap will be more than 200. So which answer? It is not possible. It is not possible. It is not possible. Now you can take what? Calculated risk. But there will be what? 1/3 negative marking, because it is a 1 mark question. So 1/3 negative marking means you can choose what? 226 or 218. So tell me which answer, A or C. Just you can guess A or C. Now we can solve it. Now 50% probability that you will get the right answer. Now what we can do? Subtract 3 minus 2. Because this gap is high, you can write EC minus EFN2 minus EC minus EFN1, subtract. When we are subtracting, KT is common, log minus it will multiply, KT log of NC by N2 into what? N1 by NC. Subtraction means what? Division. Subtraction means log A minus log B. Log A minus log B is what? Log A by B. So this is the log A by B. This is A, this is B. Now, this is no need to calculate the NC cancel out. And then this gap is required, EC minus EFN2 minus 200. This is given us. Initially, this is given as 200 milli electron volt. And in this place, you can use the 0.026 log of. What is the N1? 10 to the power 16. What is the N2? 0.5 into 10 to the power 16. Means you have to calculate the log 2. And what is the log 2? 0.693. Log 2 is what? 0.693, guys. Then it will become EC minus EFN2 is equal to 0.026 log 2 is 0.693. Multiply it plus what? 200. Remember, it is in volt. Convert it into millivolt means here you can use the direct 26. Direct 26 millivolt. Guys, definitely no need to calculate it. 26 is less than this and 200 means it is nearly equal to 218. 218. So what is the answer here? No need to use the calculator. It is not 226. 218 milli electron volt. Log 2 is what? 0.693. Now, next question. Next one. Again, one more question. Consider the CMOS circuit shown in the figure. Where is the CMOS circuit? This is the CMOS circuit. In the figure, substrates are connected to their respective sources. The gate width to gate length ratio, W by L of the transistor are as shown. Both the transistors have the same gate oxide capacitance per unit area. Right? That is the gate oxide. This is the per unit area. They have the same COX. W by L is different. W by L is 5. W by L is 1. This is the PMOS. This is the NMOS. So this is completely CMOS. For the PMOSFET, the threshold voltage is -1 volt. Yes, we have the negative threshold voltage. Mobility of the hole is 40. For the NMOSFET, the threshold voltage is 1 and the mobility of electron is 300. Always remember, mobility of electron is greater than mobility of holes. The steady state output voltage, we have to find the V0. We have to find the V0 in this particular question. Okay. Or it is given to 0, more than 2, less than 2, equal to 2. Then, watch this, guys. Here it is the gate. Here it is drain. This is the source of PMOSFET. This is the source of NMOSFET. This is called VDS. VDSN for NMOSFET. This is called VGSN for NMOSFET. And this is called VSGP. Plus minus. VSGP for PMOSFET. Now, when the drain is sorted to gate, always remember, when the drain is sorted to gate, here the drain is sorted to gate for PMOS, drain is sorted to for NMOS, for both. When the drain is sorted to gate, MOSFET will be in saturation. Means both the MOSFETs are in saturation. Now, both the MOSFETs are in saturation at the same time, they are connected in series. And what is the gate current? 0, because this is a insulated gate field effect transistor. Now this is the 4 volt and they are having the same current from this point to this point. They are having the same current. You can redraw the diagram. Okay, this is NMOS, this is PMOS. You can remove the bubble, then you can understand this is the internally connected, and that is the reason. And you have to find the V0 here. This is the 4 volt battery is connected here. Now the same current will flow because these two are connected in series. ID, same ID, same ID and same ID. Right, and you have to calculate. So what is the V? Now this is connected to ground here. This is connected to ground. That's why both are in saturation. So what is this? VGSN. This voltage is V0. This voltage is 0, and that's why it will become V0. VGSN is V0 and VSGP. What is the VSGP? This is the S terminal, this is the V0. So what is the, this is the 4 volt, this is the V0, that's why it will become 4 minus V0. 4 minus V0. And W by L for this is equal to 5. Threshold voltage is minus 1 volt. W by L is equal to 1. Threshold voltage is 1 volt. Okay, then simply because they have the same current and they both are in saturation, the current through the P MOSFET is equal to current through the N MOSFET. What is the current? You can write half of mu P COX. COX, this is for P MOSFET, half of mu P COX W by L for P MOSFET. VSGP, what is the VSGP? 4 minus V0. 4 minus V0 is VSGP minus VT. Minus VTP mod of that square is equal to half of mu N COX W by N VGSN minus VTN the square. Okay, that is it. Simple. And from these two you can find a V0. What is the value of V0? Now half cancel, COX cancel, mu P it is given as 40, W by L is given as 5 for P MOSFET. VSGP, you have calculated what is the VSGP? 4 minus V0. 4 minus V0 minus VTP mod will become, it will become 1 square is equal to, what is the mu N? 300 it is given. W by L is 1. What is the VGSN? V0. VT minus 1 the whole square. And this is 14 to 5, that is the 200. 0 0 cancel and it will become 2 times of 4 minus 3 minus V0 square is equal to, it will become 3 times of V0 minus 1 square. Now you will get a quadratic equation. You will get a quadratic equation and solve it. Then you will get 2 answers for this particular question. 2 answers for this particular question, guys. Is equal to 3 V0 minus 1 the whole square. Okay, so what is this? 9 minus 6 V0 plus V0 square is equal to V0 square minus 2 V0 plus 1. Okay, then 18 minus 12 V0 plus 2 V0 square is equal to 3 V0 square minus 6 V0 plus 1. Then guys, अब यहाँ से आप you can solve it. This is the become V0 square, that will become what? Plus 6 V0. You can check my calculation also. And I think this is the 18 will become 17 there. It's equal to 0. So please use this. My work is over. This is your work. This is the quadratic equation you will get. Now in a quadratic equation, always remember you will get the 2 answer. Yes, Venkat, you are getting the 1.9. Yes, you will get the 2 answer here. Right? One answer, what will happen? If suppose there will be 2 answer, always check 4 minus V0, this voltage. If suppose there are 2 options, always check with this. 4 minus V0 should be greater than mod of VTP. Otherwise, it will be in cutoff. Otherwise, it will be in cutoff. Second thing, this V0 should be greater than 1 volt. Otherwise, V0 is 1.9 means it is greater than 1 volt. Otherwise it will be in cutoff. Second thing, what is the, if suppose there are 2 options, always check what is the VDSN. If there are 2 options, then what is the VDSN? Because it is in saturation, so VDSN for N MOSFET, it should be greater than VGSN minus VTN. Okay, so V0 is what? If you are choosing, VGSN is V0. If it is 1.9 nearly equal to minus 1, that is what 0.9. 0.9. And what is the VDSN? VDSN is V naught, right? Then you have to choose accordingly. Are you getting my point, everyone? Are you getting my point? Because VDSN is V naught. VDSN is nothing but V naught. A VGSN is also V naught. Definitely. That is more than that. Okay. So two answers you have to verify. It should be greater than cutoff and that condition should be satisfied. What is the VSGP? Second condition. This is for NMOS. What is for PMOS? VSDP should be greater than equal to VSGP minus mod of VTP. That condition should be satisfied. This is nothing but 4 minus V naught should be greater than or equal to 4 minus V naught minus mod of that VTP. That is 1. Mod of VTP is nothing but 1. You have to verify it. You have to verify it when we are putting the value of V naught. Okay, then 1 point nearly equal to 1. So what is the answer for this question? Less than 2 volt. Less than 2 volt. Now next one. Okay, another question in 1 mark question. The ideal long channel N MOSFET and P MOSFET device shown in the figure. This is the N MOSFET P. This is the N MOSFET. Bubble it is given. Bubble means P MOSFET. Circuit have the threshold voltage of 1 volt and minus 1 volt. The MOSFET substrates are connected to their respective sources. MOSFET substrate are connected. MOSFET substrate means normally what we are doing. Body terminal is connected to what source? Substrate means body terminal. Body terminal is connected to source. It is not represent here, but okay. Ignore the leakage current and assume that the capacitors are initially discharged. For the applied voltage as shown, the steady state voltages are. Steady state voltages are. But simply that is answer V1, V2, V3 is given. Now redraw the diagram and you will get the idea. Redraw the diagram here. This capacitor is connected to source terminal. And this voltage, the gate voltage for NMOS, it is given as 5. And this is what 5. 5 volt, 5 volt. Second. This is given. This is the PMOS. This is the 5 minus 5. Why minus 5? Because it is PMOS. This is 5. And one capacitor is connected here. Right? Now remember, this is the source terminal actually. This is the drain. Here you want what? VSGP. What is the VSGP? 5 minus of 5, that is the 10. You can see. Now the current will flow here. When the current will flow, the capacitor will charge fully. So here we are getting 5 volt. No problem. This will charge up to what? 5 volt. But when we are talking about this, you have to check this one. It is when these two voltages are same, okay, no problem, because it is a drain. Drain is similar to what? Gate. That's why it is what? It is in saturation. Definitely it is in what saturation? When the drain is equal to gate, means VDS is equal to what? VGS, means this is in what? Saturation. VDS is greater than VGS minus VT. This is in saturation. And this voltage should be what? Greater than or equal to threshold voltage. So what is the greater than or equal to that? So those are that the current will flow. That is what the capacitor will charge. And what is the maximum voltage across the capacitor? It is 4 volt. Why? Because it is 5, it is 4. Then what will be the voltage here? 1 volt. You have to maintain the minimum threshold voltage here. Otherwise it will be goes into what? Cutoff. And that's why V1 is what? 4 volt. V1 will charge up to 4 volt and this capacitor will charge up to what? 5 volt, no problem, because this is what? VDS, VSDP. VSDP. Here we are getting the VSDP and this will almost act as what? Short circuit. Almost act as what? Short circuit in linear ohmic region, guys. Okay, that is the case. So 4 volt and 5 volt. This is the answer. See. C is the answer. 1 mark question in electronic devices. Very tricky question. Now next one. An ideal MOS capacitor. Again on MOS, that remember already I have given us 6 topics: semiconductor physics, PN junction, and what then BJT. So normally try to solve. We will get the question from BJT also. And then what? MOSFET, MOS capacitor, special diodes. So an ideal MOS capacitor is shown in the figure. The MOS capacitor is under strong inversion with Vg is equal to 2 volt. The corresponding inversion charge density is 2.2 micro per centimeter square. Inversion charge density. Remember, inversion charge density is proportional to what? Applied voltage minus Vt. And the constant of proportionality is nothing but capacitance per unit area, that is oxide capacitance, VGS minus Vt. That is the formula per unit area. This is the charge per unit area. Oxide capacitance per unit area. COX is equal to 1.7. For Vg is equal to 4 volt, the value of Q in is. Means again we can use what two formula, that is the Q1. This is the VGSN. Then this is the Q2. COX VGS2 minus Vt. Because Vt is same. This is the equation number 1, equation number 2. In first case we are using the 2, in second case we are using the 4. 2 minus 1. 2 minus 1, this is the Q2 minus Q1 is equal to, you can take COX as a common. Here you will get the VGS2 minus Vt minus VGS1 plus Vt. No need to calculate the Vt cancel. And then Q2 minus Q1. Q2 minus Q1 is equal to COX VGS2 minus V1. And now next time you can directly use this formula. Q2 minus Q1 is given by COX VGS2 minus VGS1. So what is the Q2? It is given 2.2 and definitely the charge will increase, that is the Q1. So what is the Q2 here? Next charge is given by Q1 plus COX VGS2 minus VGS1. What is the Q1? Please calculate it. 2.2 micrometer and 4 volt and 2 volt. And it is 1.7. 2.2. This is 1.7. Initially, this is the formula. 5.1. So what is the question asked here? Assume the ideal per unit, the value of the QI in rounded off to. In second case, what will be the inversion charge density? Now you can find. Can you find? Okay. What is the problem here? What is 5 means what? Which one 5? It will act as short circuit and MOSFET. Now first of all tell me everyone, this is the formula and you have to use this formula. Okay, check my calculation also. Then this is the formula. VGS2 minus VGS1. COX it is given and then you can find. No need to find the Vt directly. This is called easy calculation. Some students what they are doing? We are solving. They are solving for Vt and then they are using the Vt for the next question. So this is the 2.2 and 5.1. Okay. And one more, how Q is directly Q inversion charge. What is the MOSFET? What is the working of the MOSFET? Up to Vt it will use to repel the holes, and after Vt it will attract what? Electrons, and that's why the electron density is proportional to what? VGS minus Vt. Conductivity also proportional to VGS minus Vt. That inversion charge density. Again, if you want a more detail about that, yes, please write, then I will arrange one session that where I will completely explain this. So write down the topic, which topic you are finding the difficulty and so on. For example, in this case, finally it will act as what? Short circuit under ideal condition. When it will act as short circuit, it is not in cutoff. It is in a triode region, linear ohmic region, the resistance will become 0 and that's why this 5 volt, this capacitor can charge up to what? 5 volt. But here it can't. Because if it is more than 4 volt, then what will happen? This voltage will become less than what? 1 volt and it will goes into cutoff. And that's why more than 4 volt is not possible in first case. But in second case it is possible. In second case it is possible because this voltage is 5 volt, this is minus 5, it is given. It is a 10 volt and that's why it will almost act as what? Short circuit. Very high voltage VSGP. What will be the resistance? RDS. RDS is given by half 1 by K and S VGS minus VT into W by L. That is all. Because VSGP, for example, if you are writing for the PMOS, VSGP minus mod of VTP. And because this is very high, the resistance is very small, and almost it will act as what? Short circuit. Okay. Next one. Consider an ideal long channel MOSFET enhancement board with gate length 10 micrometer and width 100 micrometer. Length is given, width is given, W by L ratio you can find 100 by 10, that is what? Unit cancel, and 10. W by L ratio is 10. Oxide capacitance per unit area is mu n CUX. The product of that, this is called K and S, is equal to mu n CUX. That is given as 1 milliampere per volt square. The threshold voltage of the transistor is 1 volt. VT is 1 volt. For a gate to source voltage, VGS is equal to 2 minus sine of 2t. 2 minus sine of 2t, and the drain to source voltage is 1 volt. To the source, the maximum value of the drain to source current is, maximum value of the drain to source current is, right? Drain to source current is maximum value. Now there will be two cases, whether it is in a triode region or it is in what? Saturation region, when we are going to get the maximum current, because it is a sinusoidal signal, 2 minus sine of 2t, because the input is 2 minus sine of 2t. So what is the maximum value of the input? 2 plus 1, because sinusoidal signal is what? Sine signal. What is the minus 1 to plus 1? When we are putting the minus 1, minus plus, so what is the total voltage? 3 volt maximum. What is the minimum value? 2 minus 1, that is the 1 volt. So from 1 volt is greater than 3 volt, 3 volt is also greater than VT. It is greater than or equal to VT, it is also greater than VT. And that's why throughout the range of the input, it will be in conduction mode. It will be in conduction mode. Now there will be two cases, triode region and saturation region. Now you have to use the formula for the triode region. What is the triode region? In triode region, the current is K and S, W by L, VGS minus VT into VDS minus half of VDS square, right? VDS is given 1 volt in this question. Watch this. The threshold voltage of transistor for gate to source voltage and the drain to source voltage VDS 1 volt fixed. The maximum value of the drain to source current is VDS is fixed. Now here in this formula you can use the maximum value. So K and S mu n COX. What is the value of the mu n COX? 1 milliampere. This is 10. 1 milliampere. This is 10. VGS. Maximum you can use the VGS. What is the maximum value of the VGS? Minus 3. VT is 1 volt. VDS 1 minus half of into 1. Now this will become 10. This is the 2 minus 0.5. That is what? 15 milliampere from the triode region. 15 milliampere from the triode region. Now what from the saturation region? In saturation region, the formula will become half of K and S W by L VGS minus VT the whole square. This is in saturation region, guys. And remember, in the saturation region, what is the condition? VDS should be greater than or equal to what? VGS minus VT. What is the VDS? It is given 1. What is the VGS minus VT? If suppose you want to use the maximum value, then again it should be equal to what? 1. Because VDS 1. VDS set, that is equal to what? 1. So what is the value of the VGS? 1 plus VT. You can use maximum value, that is what? 2 only. Maximum value you can use only 2. Use the 2 only. If you are using the 2, it will become half of K and S is nothing but 1. W by L is 10. what is the VGS? 2 minus 1 the whole square. You will get maximum current 5 milliampere in case of saturation. Only 5 milliampere in case of saturation, and in case of triode you will get the 15 milliampere, right? So 15 milliampere. Sir, कैसे पता चलेगा कि ये ट्रायोड दोनों? We are considering both Akanksha वशिष्ठ, we are considering both region. Let it is in triode region, let it is in what? Saturation region, because we have to find the maximum current. And the VDS is given, the fixed VDS is given. Fixed value of VDS is given. What is the value of the VDS given? 1 volt. And that's why when I am considering triode region, for example, in a triode region, so what I have taken the VGS maximum 3. So what is the VGS minus VT? 3 minus 1, 2. And what is the VDS given in the question 1? That's why we can say the VDS is less than what? VGS minus VT. And this is in which region? Triode region. In a triode region, first find the current, that is what? 15 milliampere. In the second case, we are assuming that it is in saturation. When it is in saturation, but there is one condition, it should be greater than or equal to that. It is fixed. So you have to use what we can use the maximum value of VGS. When we are equating it, you can use maximum VGS is equal to 2 volt, not more than that. When I am putting the 2, I am getting only 5 milliampere. So what is the maximum current? 15 milliampere. That is in triode region. Okay, any doubt? The answer is 15 milliampere. Now, last, so this is we will discuss the question 2023 within 10 minutes. If suppose some questions will remain, then we will arrange extra session for that. Now, this is you can download app from our Google Play Store. Try to give the mock test and you will get the leaderboard here. How many number of students participated in that test? What is your rank? What is your score? And कितने पानी में हो आप? कैसी preparation चल रही है? Each and everything you will get from this. Okay. So if suppose you have downloaded the BYJU'S Exam Prime, okay. But if you want link of that link is given in description box. Go through it, join and attend my session, attend sessions of all other faculties. It will definitely boost your confidence also. Number of papers are also available. Previous year questions are also available, not 2023. Now, first question. In a 2023, only you will find difficulty in only 1 or 2 questions. Already I have uploaded the solution for the 2023. Go through it. GATE Electronics 2023 solution. You will get very detailed solution for all questions. So quickly I am going to discuss it. Then you can go through it just after the session. In a semiconductor, if the Fermi energy level lies in the conduction band, then the semiconductor is known as. If the Fermi level enter into the conduction band, means there is very, very high doping. Fermi level enter into the conduction band. For example, here we are getting the Fermi level. This is it. So non-degenerated, we have solved one question. Low doping. Degenerated semiconductor means very high doping. Tunnel diode. In tunnel diode, we are having the very, very high doping. So Fermi level will enter into the conduction band. The answer is A for this question. Degenerate, or what is given? Fermi level lies in the conduction band, and that's why it is N type. If it lies in the valence band, then it will become P type, right? P type. So this is a first question. Second, for an intrinsic semiconductor at temperature 0 degree Kelvin, which of the following statement is true? Any semiconductor, whether it is intrinsic or extrinsic, exactly at 0 degree Kelvin, 0 degree Kelvin means minus 273 degrees centigrade, it will act as what? Insulator. Insulator means there is no electron in conduction band, no free electron in conduction band, and no holes in valence band. All the electrons will be in valence band only. Electrons are not getting the sufficient energy to switch from valence band to what? Conduction band. They will not going to switch here. They are not having the sufficient energy to switch from the valence band to what? Conduction band, and that is the case. So all energy state in the valence band are filled with electrons, and all energy state in the conduction bands are empty of the electron. all energy state in the valence band are filled with the electrons and all energy state in the conduction band are empty of the electrons. Is it clear? This point is clear? Okay. पूरे इलेक्ट्रॉन आपके वैलेंस बैंड में होंगे, कोई भी कंडक्शन बैंड में नहीं जाएगा. ओके, देयर इज नो कंडक्टिविटी. नाउ third question, for a MOS capacitor, VFB means flat band voltage, VT are the flat band voltage and threshold voltage respectively. The variation of the depletion width for varying the gate voltage is the best represented by. If you have the idea about the characteristics, then you can draw the characteristic like this. What is the CMOS characteristics? CV characteristics, this is called. This is the C, this is the V, VGS. Accumulation mode, then in a flat band, then the depletion layer increases, it will reach to maximum. Then this is called inversion and strong inversion. Exactly at VT, we are having the maximum depletion layer and minimum depletion capacitance. And here we are getting the C minimum. And this is called C maximum. This is nothing but oxide capacitance. This is called accumulation mode. This is nothing but depletion. Here the depletion layer increases and it will reach maximum at what VT, and after that there is no change in the depletion layer. Inversion is started. This is called inversion and that is called strong inversion. So when we are comparing with what about the flat band voltage? Negative. This is the flat band voltage here for P-type body, N-channel MOSFET. Now what about the depletion layer? Depletion layer will start increasing from this point and it will reach to maximum at what VT, and after that it will become constant. That type of curve we should get. Depletion layer will start increasing from the flat band voltage, reach to maximum exactly at VT, then after that it will saturate. Which curve? You can say, sir, there are two types of curve, this one and that, but it is saturated at what? 0 voltage only. After 0 it is constant. It will start from the flat band, after 0 it is constant. Now here start from the flat band, reach to maximum at the VT and then constant. Yes, this is the B is the answer. B is the answer for this question. Okay, so that is about what MOS capacitor. To get everything about the MOS capacitor, guys. Everything about the MOS capacitor, because this is very very important topic for what gate examination. अच्छा ठीक है ना, एक बार कमांड होगी, it will help you in VLSI. तो VLSI में तो MOS कैपेसिटर का बहुत ज्यादा रोल है, तो आपको ये भी हेल्प मिलेगी, इंटरव्यू में भी बहुत हेल्प करेगा ये टॉपिक. ओके ना, EDC. Now, two more question. In an intrinsic semiconductor, the hole concentration is given to be, this is a very very easy one. Hole concentration is given as 1.5 Ni, where Ni is the intrinsic carrier concentration of 10 to the power 10. The ratio of the electron to hole mobility for equal hole and electron drift current is given as. In an extrinsic semiconductor, the hole concentration is given as 1.5 Ni. The ratio of the electron to hole mobility for equal hole and electron drift current. For example, if it is the hole concentration, what is the drift current density because of the electron? It is given by AJ, excitation, A sigma E. What is the A sigma E? A N Q mu N into E. And what is the IP? A sigma E. It is given by AP in place of Q mu P by E. And the ratio, the current, both the currents are same. So when we are dividing the equation number 1 and equation number 2, then it will become IN by IP, that is nothing but 1. Why 1? Because these are current, drift current, AA cancel, everything is cancel, N by P, QQ cancel, mu N by mu P, EE cancel because we are giving the same electric field. This is 1. So what is the mu N by mu P? The mu N by mu P will become P by N. Now what is the concentration of hole? 1.5 Ni. So what is the concentration of electron according to mass action law? Ni square by P. So it will become Ni square by 1.5 Ni. So that is Ni cancel, and this will become Ni upon 1.5. Ni upon 1.5. Now put here, it is 1.5 Ni upon Ni divided by 1.5. It will become 1.5 the square. 1.5 square, that is what? 2.25. 2.25. Yes, Venkat, I will arrange for that. 2.25 is the ratio. Very, very simple question. You have to use the formula for the drift current only. Drift current, and it is a 2 marks numerical answer type question in 2023, guys. और कौन बोल रहा था sir, can I leave the electronic devices and circuit? Yes. Who asked this question, sir, can I leave the electronic devices and circuit? No need to leave. Get the command over 60 to 70% easy portion of EDC. Suppose if you are going to leave the EDC and you are getting the very, very simple question, then just you are going to lose what? 2 marks here. Okay. So first of all, get the command over 70% easy portion of EDC, guys. Okay, last one, and that is homework for you, because I have solved. If you want the detailed solution, please type solution for GATE 2023 solution. You will get the complete solution. I think from question number 18 to what? Question number 36 or 37, I have explained EDC analog, complete EDC analog, as well as I think network also. You can go through it and solve these questions. This is a homework for you. First of all, try to solve this question. Then for detailed solution, you can go through that particular session, guys. 4 months back, I have recorded that. Now, already we have started the GATE crash course, guys. This is a course for electronics branch. That is the course for electrical branch. We are providing the live classes, recorded lectures, study material, practice quizzes, mock tests. And these are the cases, and this is the number you can call at this number. Thank you very much for attending the session. You are on BYJU'S exam prep, guys. This is my channel, Electronics by Sanjay Rathi. I will upload the PDF. You have to join this. Right, number of PDFs are available, number of notes are available, and I am trying to give daily question, daily का dose, तो ताकि आप लोग भी थोड़ा सा एक्टिव रहे उस चैनल पर. तो आए जरा और सजेस्ट भी कीजिए टॉपिक्स, कौन कौन से टॉपिक में आपको सेशन चाहिए. Okay guys, okay then, thank you very much for attending the session. Like the session, share the link of this session and subscribe our channel. Who is overloaded now?